My name is Fonseca-Lopez, and this is my Lab 2 on projectile motion. It's just a small overview of what I'll be discussing. I'll do a brief introduction, talk about some of the applied physics concepts, go through my experiment procedures, show off my two computational models, make a comparison between the experiment and the computational models, and then answer some additional questions at the end. So the purpose of this lab was to analyze the motion of an object as it falls with all the forces acting on it. We compared the observations of two computational models, one which only accounts for gravity, and another which accounts for both gravity and drag force. The tools used during this experiment were Tracker to analyze the portion of the video, GlowScript to create two computational models, and Google Sheets to compare the data of the three. Some of the applied physics concepts were first, Newton's second law, which in our case will tell us that the acceleration on an object is equal to the net force divided by mass of the object. And if we take the initial formula, F net equals ma, we can derive the velocity update formula and the position update formula, which we will use during our experiment procedure. Then we have gravitational force, which tells us the attractive force that pulls objects together. And in our case, it pulls downwards at 9.8 meters per second squared due to Earth's gravity. We also take into account drag force, which is the resistance on an object as it moves through a fluid. And in our case, it's the resistance our object experiences as it moves through the air. My experiment procedure. First, I recorded a video of a paper ball thrown over a table using a notebook as a calibration stick. Then I imported the video into Tracker and I utilized the tracking feature to analyze the object's motion frame by frame. Next, I used GlowScript to create two computational models to predict the object's position. One model will only account for gravity and the other model will account for both gravity and drag force. And using the data from Tracker and the computational models, I'll create a graph on Google Sheets and I'll compare the models of each one to reach a final conclusion. So here's my Tracker setup. My system was on paper ball. My surroundings were everything else, just gravity and air resistance. I have my initial position and initial velocity, which I calculated using the first two frames of the video. The mass of the paper ball was 0.030 kilograms. And my total time of the analyzed portion of the video was 0.384 seconds. So here's my computational model with no drag force. I updated the mass of the ball, the initial position and velocity. I changed my delta t according to the frame rate of the video. Gravity was left at 9.8 according to the gravity of the Earth. B was left at 0 to account for no drag force. And I had to calculate for the net force and update the position and velocity according to the momentum principle. So here's my computational model with drag force. Everything stayed the same, except now my B was 0.00125, which was a air resistance I found that matched my observational model the best. So here's a comparison of the three. As we can see, the sphere that experienced no drag force traveled much further than the other two. And while my observational model deviated slightly from my model with drag force, we can see that it does align very similarly, showing that they both experience a similar drag force. So some possible sources of error. The shape of my paper ball was not perfectly round like the balls in the simulation, so the air resistance could have been affecting it differently. There could have been some bad placement of tracker points on my part, which would explain why the graph deviated slightly from the computational model. And there could have been other forces affecting my system that I didn't take into account. So some additional questions. What does it mean? And do any of my models predict the terminal velocity? While none of my models showed a terminal velocity being reached, because the time frame was too short, if I allowed the computational model with drag force to run over an experimental period of time, we would eventually see it reach terminal velocity. And for my what if question, would the time this object takes to reach the ground or floor be the same, longer, or shorter than the time it took in my original experiment? If I threw my object straight up with the same speed as my experiment, the time it takes to reach the ground, which in my case was the table, would be longer because it needs to travel a greater distance than if it just traveled the arc over the table like it did during my experiment. Thank you for listening.